Okay, so here we have our paper publishing program in Uppaal, and we're going to demo the non-determinism so that I don't forget how this works. So we're going to step through this, and you can see here we are going to step through the machine, and the machine is ready with its coffee, but the person is not ready to receive the coffee. So although this is an urgent channel, we can't actually move there because we're not ready to receive it. Which then means that we have, we need to take a transition, and because there's no constraints on either of these transitions relating, to the current state of the machine, we can take either one because we're non-deterministically going to choose one of these and just sort of spin off into the future. So you can choose to spin off into the future in this direction or spin off into the future in that direction. So that means that we are able to go into the unhappy state here, which we don't want. So what we're going to need to do is change this one to urgent so that when we get here, we've frozen time, which means you can only take transitions that are valid with the current time constraints. Or you can only you can take any transition, but you can only move to a state that's allowed by its invariance with the current time constraints. So time is frozen, so we definitely can't move over to this one, but because time is frozen at this point in time, this is still going to be a valid state. So no non-determinism when we're frozen. This means we step forward, and now we've stepped to this state. So now we want to know, why can I only do this one but not this one? Well, we are saying that in this state we have the invariant that y is less than or equal to 4, and that means it's possible that y is equal to 3. And since this is a possible state, we must take we must first take the transitions that are available to us before we start doing any sort of non-determinism. This means we can't spin off into the future and look at this one, because this is an option without looking into the future. So we must take it, and we do not end up here. So let's see another version of this. We've got the same program here with a different configuration. So here we're again in a urgent state, which means we've frozen time, which means we can only take ones that are available to us. We cannot spin off into any non-determinism. So we step forward into this state, and now at this point we said y is less than or equal to 5, which means that this is the only thing that's available to us. By writing this invariant, we've locked in our time, and we said this is exactly where we are, within this bound. So since this guard on the transition falls within this bounds, we have it available as a transition. We must take it now, and we cannot non-deterministically go into the future and look for this one. Now, if we changed this to a 6, we would be stuck in deadlock because we've locked ourselves into this time. And again, even though we can't take any transitions, we're not going to spin off and non-deterministically look into the future, because we've said we are definitely here. But if we were to get rid of this invariant, now once we get to this state, we need to look into the future in order to figure out what to do next. So we need this non-determinism. Since we haven't locked ourselves into a time, we're going to have to figure out what's our next transition. Is there anything non-deterministically in the future going to be available? Because these clocks just keep running if you don't tell them not to. So now we can either go this way, or we can end up in a state where our advisor is unhappy.